Hi again, pre-algebra students. This video discusses section 4.1, Introduction to Fractions and Mixed Numbers. So please have your handout today with you as we go through this. The first part of it's going to be a lot of definitions. What's true about fractions and mixed numbers. So that won't be on the handout, as I usually just put the problems that we're going to do in class on the handout. So you might want to take additional notes about these definitions with fractions and mixed numbers. I have good news for you. 3 out of every 2 people have trouble with fractions. So you're not the only one. And hopefully that doesn't make sense to you. And we'll talk more about that in a minute. So fractions are everywhere. This unit is crucial. It's so important because we use fractions everywhere. Measurement, architecture, cooking, welding, time, sports, nursing, medicine, pharmacy, art, etc. all uses fractions. Today I looked at my gas gauge in my car and it was down to 1/8 of a tank, fraction. Or when I poured my milk for my bowl of cereal, it was half full, 1/2, fraction. Fractions are everywhere. So let's just first break down what a fraction is. A fraction has a top number, called the numerator, and the bottom number, which is called the denominator. And then there's a line in between them, which is called the fraction bar. Okay, all the fraction bar means is division. That just means 5 divided by 6 means 5/6. 5 is the number of parts being considered. There's 5 parts considered over the total number of equal parts of 6. So if I say I have 3/4 of a tank of gas left, there's 3 being considered, 3 left, out of 4 equal parts in the whole, 4 equal quarters. Okay, so every fraction has a numerator and a denominator with a fraction bar in between it, and it's important to remember all that means is division. All we're doing is division. You know how to do division as we did it in Unit 1 and in Unit 2. So let's just think of it as division. So identify the numerator and denominator of each fraction. 11/2, the numerator is 11, the denominator is 2. 10y over 17. The numerator is 10y, the denominator is 17. Alright, so there's going to be a bunch of homework problems using graphs or pictures to represent fractions. So in this case, we have 1, 2, 3, 4, 5, 6, 7 equal parts on this graph, and 4 of them are shaded, which means the fraction is 4 parts out of the total of 7 equal parts in the whole, so 4/7. Another example, there's 10 equal parts in the whole, 3 parts are full, so the fraction would be 3 out of 10, or 3/10. Okay, whoops, I gave it away there. Okay, here's a pie. 5 are shaded out of 6 equal parts. 5/6 is the fraction. Okay, another way to draw it would be like this. 5 parts are shaded out of 6 equal parts. 5/6. Alright, there's 2 types of fractions. There's proper fractions and there's improper fractions. A proper fraction is one that you're used to. It's when the numerator is less than its denominator. So 3/8, or 3/4, or 1/2, or 1/4. When the top number, the numerator, is smaller than the denominator. It's called a proper fraction. It's improper when it's the other way around. When the numerator is larger than the denominator. We don't usually say 10/4. We usually rewrite it as 2 2/4, or 2.5. We won't usually say 8/3. Usually we break it down to a mixed number. So proper fraction has a numerator smaller than the denominator, and an improper has the numerator larger than the denominator. Okay, with an improper fraction, we often rewrite it as what's called a mixed number, which we'll talk about in a little bit, how to convert from improper to mixed numbers, and mixed numbers to improper. A mixed number is this, 2 2/4. It has a whole number part and a fraction part. We'll look at that in a minute. Okay, another way to visualize is to graph them. You can graph any number on a number line. So to graph 3/5 on a number line, here's 0, and here's 1. 1 means 5/5, or one whole number. So you can break it down into equal fifths. To do that, you make 4 lines in between, because this has 1/5, another fifth, another fifth, another fifth, and another fifth. We want 3/5, so it would be the third one down would give us 3/5. So remember, this is 1/5, 2/5, 3/5, 4/5, and 5/5 is a whole number, one whole. Okay, so to graph 3/4 on a number line, you'd go between 0 and 1. We need to divide it into 4 equal parts, which means we put 3 lines in between 0 and 1, so we have 4 equal parts in between 0 and 1. So 1/4, this is 2/4, 3/4, and 4/4. Remember, 2/4 is the same thing as 1/2. So to graph 3/4, it would be right there. Okay, it does get a little bit more difficult when you're graphing an improper fraction. Now 7/3 means we need to break it down into thirds, like this, 1/3, 2/3, this is 3/3. So we can't just stop between 0 and 1, because it's over 1. 4/3, 5/3, this would be 6/3, and 7/3 would be right there. Okay, so 3 equal parts for each between each whole number. Go to the 7th one. Alright, so as we talked about, any fraction, all a fraction is a division problem. So as we talked about in Unit 1 with division, there's some division properties that we have to remember. The first one is any number divided by itself is 0. So any number divided by itself is 1. 6 divided by 6 is 1. 10 divided by 10 is 1. 8 divided by 8 is 1. Okay, 8/8 means one whole number. The second one is 0 divided by any number is 0. 0/4, 0/3, 0/6, 0/10 is the same thing as 0. Okay, any number divided by 1 is itself. So 6/1 is the same thing as 6. 3/1 is the same thing as 3. 4/1 is the same thing as 4. And the last one, any number over 0 is undefined. 6/0 is undefined. 7/0 are undefined. You can't break a number down by 0. You can't divide by 0. Some examples of this: 9/9 is the same thing as 1. 0 over -1, -6 over -6 is 1. 0 divided by -1 is 0. 5/1 is the same thing as 5. 13/0 is undefined, and -13/1 is -13. Okay, now on to the good stuff, and this is where you'll need your handout for this part. How to convert an improper fraction to a mixed number. Okay, so to do that, I'll come back to the explanations. Let's say the first example on our assignment says 9/5. Remember, that means 9 divided by 5. Okay, so all we do is we divide. How many times does 5 go into 9? 5 goes into 9 one time. So remember, you take 1 times 5 is 5, and there's 4 left over, which means it's 1 4/5. Okay, again, you say how many times does 5 go into 9? 1 whole time, with 4 left over. That's your remainder over 5. So 1 4/5 is the same thing as 9/5. The second one says 23/9. So you ask yourself, how many times does 9 go into 23? Well, 9 times 2 is 18. So the whole number would be 2. 9 times 2 is only 18, which means we're 5 short from 23. Okay, which means our remainder is 5. So we're left with 2, 9 goes into 23 twice, with 5/9 left over. So 2 5/9. Okay, and that's what these instructions here say. This is right out of your textbook. If you want to write this down. To write an improper number as a mixed number, divide the denominator by the numerator, or into the numerator. And then take your remainder and write it over the original denominator. Okay? Let me know in class if you have any questions on that. So your assignment here would be to do letter C, which says 17/5, and letter D, 31/6. I want you to have those done when you come into class. So make sure you do those, and I will take a look at those as your ticket into class. All right, what if we're going to go the other direction? What if we have 5 2/7 and we want to write that as an improper fraction? Okay, so now we go the other direction. What you do is you take 7 times 5, and that gets you 35, and then you add the numerator to get 37. So again, the denominator times the whole number gets you 35, because the whole number 5 means 35/7 if you were to rewrite it with the denominator of 7. So 7 times 5 is 35, plus the 2 gives you 37/7. For 4 1/5, same idea. You take 5 times 4 is 20, add the 1, and that's the same thing as 21/5. So 21/5 is the same thing as 4 1/5. So the directions on that would be to multiply the denominator by the whole number, and then add the numerator, and write that answer over the original denominator. And again, that can be found in your textbook. Okay, so why don't you go ahead and try letter C, 3 5/6, write that as an improper fraction, and letter D, -2 6/7. Now that one's a little bit tricky because it's negative. What you do is ignore the negative and just write negative in your answer. So do 7 times 2 plus 6 and write it over your original denominator of 7, and then don't forget the answer is negative. Okay, and then there's 2 other questions left on your handout here. So let's take a look at number 3. It says there are 72 counties in Wisconsin. 11 of the counties have casinos. What fraction of the counties have casinos? Okay, so that would be the part that do have casinos over the total number of casinos. So in that case, there'd be 11 out of 72. So 11 over 72 would be the fractions that have casinos. What fractions do not have casinos? Well, first of all, you'd have to find the number that do not have casinos. And it looks like that would be 72 minus 11, which is 61. So that gives us 61 out of 72 do not have casinos. Okay, so that's how you do that one. So why don't you go ahead and try to do number 4. In a classroom of 22 students, 10 of the students are freshmen. Find the fraction of freshmen to the total number of students. Find the fraction of non-freshmen to the total number of students. And find the fraction of the number of freshmen to the number of non-freshmen. Now some of those you're going to be tempted to reduce them if you've done reducing fractions before. You do not have to reduce them, as that's what we're going to talk about next unit, or next section. So that'll be a good introduction to section 4.2. Alright, so go ahead and do that, number 4. So again, for class, I would like you to have C and D done from number 1, C and D done from number 2, and number 4. Go ahead and attempt those, and when you come into class, I'll take a look at them and see how you did, and then you can begin working on your homework. Alright, thanks for watching this. Go ahead and watch section 4.2 if you have time. Have a great day, bring some questions to class, and we'll see you there.